In this video, I will be solving the basic quant section of Saad Amir's new GRE mock that he has uploaded on his Instagram. I am a former student of Saad Amir's who scored a 170 out of 170 in the quant section of the GRE when I took the exam. I highly encourage everyone watching this video to pause the video before every question before they see me solve it and try to do it themselves. If you have any concerns or questions, please comment down below and they will directly be addressed by Saad in the coming few days. So let's begin. Question number 1 is quantity A is the number of unique prime factors of 22 and quantity B is the number of unique prime factors of 64. So let's just factorize these two numbers, 2 and 2, 11. This can't be further factorized, so quantity A is 2. 64 on the other hand, let's do that. 2 into 32, 2 into 16 into 2, 2 into 8 into 2 into 2, 2 power 8 is simply 8 is simply 2 power 3 into 2 into 2, all 1 3 1 1, so this would be 2 power 6. There's all of 2 power 6 is equal to 64, so quantity B, there's only one unique prime factor of 64, which is 2, and as a result quantity B is going to be 1, since because of the word unique. And for quantity A, the unique prime factors are 2, so 2 is greater than 1, and as a result the answer is A. Question number 2. The length and width of rectangle W are M and N respectively, and the diagonal of W has length 14. So let's just draw a rectangle. This is the diagonal. It has a length of 14. The length is M and the width is N. This would be 90 degrees since it's a rectangle. So 14, we'll apply the Pythagoras theorem here. 14 square is equal to M square plus N square. M square plus N square is equal to 14 square would be 14 into 14, 196. Now let's look at the quantities. Quantity A is 196, quantity B is M minus N square. So quantity B, M minus N square. Let's simplify this. M square minus 2mn plus N square. M square plus N square we already established from the statement given is 196. So that would be 196 minus 2mn. 196 is quantity A and quantity B is 196 minus 2mn. So M and N. So to find out which quantity would be greater, we have to see what values of M and what could be the values of M and N basically. And M and N will always be positive. And the reason why they will always be positive is because it's specified in the statement that we have a rectangle W. If either M or N are equal to 0, then we wouldn't have a rectangle anymore, which is why we can't assume M and N to be 0. It's not possible for them to be 0. Since this is a negative number being subtracted from 196, quantity A will be greater. As a result, the answer is A. In a classroom composed of 40 students, 6 over 10 of the students are female. 40 students in total. 6 over 10 of the 40 students are female. So 40 into 0.6. 24 are female and 16 are male. 4 over 5 of the students are shorter than 70 inches. 4 over 5 of the total number of students In a classroom composed of 40 students, 6 over 10 of the students are female and 4 over 5 of the students are shorter than 70 inches. So 4 over 5 is 0.8 into 40, 32. 32 are shorter than 70 inches and 8 are not shorter than 70 inches. So what are they asking us? Quantity A is 20. Quantity B is the number of students in the classroom who are female and shorter than 70 inches. So both female and shorter. So we have 24 females, 16 males, 32 are shorter than 70 inches and 8 are not shorter than 70 inches. So we need to assume different extremes here. So let's say all 24 females, one extreme would be all 24 females are shorter than 70 inches. All of them are shorter than 70. And in this case, quantity B would be 24, which is greater than 20. However, it's not necessary that all of them would be shorter. Let's say 8 are not shorter than 70 inches, right? 8 students are not shorter. Let's say all 8 of these are female. 8 females, not shorter. That leaves us with 24 females, and since 8 of them we've already established are not shorter, we've assumed 24 minus 8 would be 16. In the next extreme case, 16 females would be shorter than 70 inches, assuming that these 8 people who are not shorter than 70 inches are all female. So in this case, quantity B would be 16 in the next extreme case, and this is less than 20. In the first case, it's greater, quantity B is greater than quantity A. In the second case, quantity A is greater than quantity B. So there's no way to tell without any additional information. As a result, the answer would be D. Question number 4. So y power g minus 1 raised to the power g plus 1 is equal to y power 15, and y is greater than 1. So we can multiply the powers out. G minus 1, g plus 1 is equal to y power 15. Since the bases are the same, y and y, we can make the powers equal to each other. G minus 1, g plus 1 is equal to 15. So let's multiply them out. G square plus g minus 1 is equal to 15. G and g cancel. G square minus 1 is equal to 15. G square is equal to 15 plus 1. G square is equal to 16. G is equal to plus minus 4. So G is equal to negative 4 or G is equal to 4. Whenever we take the under root, like we're taking over here, we end up with plus minus numbers in the resulting answer. So what are they asking us? Quantity A is 1 and quantity B is the sum of all possible values of G. So for G, we have two possible values, minus 4 and 4. So minus 4 plus 4 would be equal to 0. Quantity B is 0, quantity A is equal to 1, so 4 would be A. What percent of 2 over 5 is 5 over 6? So to translate this into math, translate this English into math, 2 over 5, what percent of this number into, let's take the percent of it, into x percent is 5 over 6. So to find x, we'll just simplify this equation. 5 over 6. 1s are, 5s are, x over 0 to 22, x over 250 is equal to 5 over 6. Let's cross multiply. X is equal to 5 into 250 over 6. 2 3s are 6. 1, 2, 5. So we're left with 125 into 5. 625 divided by 3. X is equal to this much, but we need to convert this into mixed numeral, and the way we'll do that is by using long division. So 625 and 3. 3 2s are 6. 0 to 25. 0 to 5. 3 8s are 24. Left with 1. So 208 wholes, 1 over 3. This would be the answer. The answer is B. So we're on data interpretation. In 1974, let me read the graph. Foreign trade of country X from 1964 to 1980, billions of dollars on the y-axis and year on the x-axis. In 1974, the dollar value of imports is the solid line, not the dotted line, was approximately what percent of the dollar value of exports? So in 1974, the dollar value of imports was approximately 3.8, and in of exports was a little over 14. Let's just say 14.1. So what percent of 14.1 was 3.8? That's what they're asking us. Let's just use the calculator for this. 3.8 divided by 14.1. 3.8 divided by 14.1 into 100. 26.9. Approximately 27%. The answer would be C. For how many years shown on the graph did exports exceed imports by more than 5 billion? So, not 64, not 65, not this, not this, not this, not this, not 70, not 71. 1972, yes, exports exceed imports by well over 5. 1973 as well, 1974 as well. Let's check 1975. So 1, 2, 3, 4, 5. Yep, 1975 is also okay. 1976. 1, 2, 3, 4. A little, this is like 4.5. So 1976 is not included. For 1977, yes, that would be. You can just tell by how much the gap is. 1978 is 1, 2, 3, 4, 5. Yeah, 1978 is also alright. 1979. 1, 2, 3, 4, 5. Yeah, 1979 is also okay. 1980 is clearly not. So how many ticks do we have? 1, 2, 3, 4, 5, 6, 7. 7 ticks. The answer would be 7. The answer is B. So we're on the third question of the data interpretation, which is usually the hardest one. So what are they asking us? If it were discovered that the import dollar amount shown for 1978 was incorrect and should have been 5.3 billion instead, what is it right now? It is approximately 7, and it was 5.3 instead, then the average arithmetic mean import dollar amount per year for 17 years would be how much less? So we need to calculate two averages and calculate the difference between them. So the average, we'll calculate it by total import dollar amount over number of years. This would be the average. So we need to calculate the total import dollar amount for 17 years using the incorrect value of 7 billion and the new correct value of 5.3 billion. Find the average and then see what the difference between the two averages would be. So I'm going to have to look at every single import value for all of these years. So let's start with 1964. It is a little over 1. Let's say it's 1.6 plus. I'm just going to put a tick to see which year is done. Then 1965 is 2 plus 2. 3. 1966 slightly over 2. That's 2.1. 1967 is 3. 1968 is 2. 1969 is slightly over 3. Slightly over 2, sorry. So it's 2.4. 1970 is approximately 2.5. I'm just using approximate values. We don't need exacts. 1971 is slightly over 3. plus 3.1. 1972 would be a little under 3, so let's 2.6. 1973 would be 3.2 approximately. 1974 would be almost 4 plus 3.9. 1975 is exactly 4. 76 is exactly 5. 77 is slightly under 6, 5.8 let's say. 78 would be, the incorrect value is 7. 79 is a little over 6, 6.5, plus 1980 would be 8.6, let's say, approximately. 65.3. So the numerator is 65.3. Number of years is 17. Divided by 17. This comes out to be 3.84 billion. This is the old average with using the incorrect value of 7 billion for the year 1978. But they've said that the dollar amount was incorrect and should have been 5.3. So 65.3, we'll subtract the incorrect value 7 and we'll add plus 5.3. 63.6. 63.6 divided by 17. So the new correct average is 63.6 divided by 17. 3.74 billion. So we need to 3.84 minus 3.74. That's what they're asking us. How much less is the new average than the old average? So this is approximately 0.1 billion. 0.1 billion approximately. And billion has, since the options are in million, we'll just, billion is 9 zeros and we need to multiply 0.1. So without even doing any further calculations, I know that it will be 1, then 1, 2, 3, 4, 5, 6, 7, 8. 1, comma, we just put the commas to divide. 6 zeros is 1 million and we have 100. So 100 million would be the difference between the old average and the new average. As a result, the answer is going to be A. So question number 9. In the xy plane, the graph of y plus 15x is equal to 5x cube intersects the x-axis between x is equal to 1 and x is equal to at how many points? So y plus 15x is equal to 5x cube. Y is equal to 5x cube minus 15x. So intersects the x-axis. When any graph intersects the x-axis, the y value will be 0. So y will be equal to 0 when it intersects the x-axis. And that's what we need to find. Where does it intersect the x-axis, at what points? And do those values lie in between 1 and 2? So 5x cube minus 15x is equal to 0. 5x is equal to x square minus 3 is equal to 0. So 5x is equal to 0, or x square minus 3 is equal to 0. X is equal to 0 over here, or x square is equal to 3. X is equal to plus minus under root 3. So x is equal to 0, x is equal to under root 3, x is equal to minus under root 3. So what is under root 3? 3 under root is 1.73, negative 1.73. So these are the three values of x. They've said intersects the x-axis between x is equal to 2 and x is equal to 1 and x is equal to 2 at how many points? So let's just draw an xy plane. This is 1 and this is 2. 0 lies over here, negative 1.73 over here, and 1.73 would be here. So it intersects the x-axis at only one point between the points 1 and 2. So the answer would be B. Option B is correct, 1. So what do we have here? Two cylinders. Let's read the question. Two water tanks are right circular cylinders of different sizes. The interior base of tank P has an area of 3.5 pi square centimeters, and the height of the water in tank P is 3 centimeters. So before reading the question further, let me just, the area, the interior base area is 3.5 pi, right? I want to calculate the radius before I move forward. 3.5 pi is equal to pi r square, right? Pi cancels out. R square is equal to 3.5. R is equal to under root 3.5. This is the radius of tank P. The interior base of tank Q, on the other hand, has an area of 8 pi square centimeters, and the height of the water in tank Q is 10 centimeters. So let's just calculate the radius for tank Q. 8.5, sorry, not 8.5, just 8. 8 pi is equal to pi r square. Pi cancels out. R square is equal to 8. R is equal to under root 8. This is radius for Q, this is radius of P. And the height is 10 centimeters. Water is to be moved from tank Q to tank P so that the height of the water will be the same in both tanks. Which of the following is closest to what will be the new height of the water in centimeters? So water is to be poured from tank Q to tank P. So we need to calculate the volume of both these, of both the tanks. So for tank volume of P would be the base area, which is given 3.5 pi, into the height, which is 3. 3.5 into 3, 10.5 pi. And the volume of Q would be 8 pi into 10, which would be 80 pi. So the total volume of P plus volume of Q would be 90.5 pi. This is the total volume of both the tanks combined. So they're asking us which of the following is closer to what will be the new height of the water in centimeters. So we have the two radiuses, we have the total volume, and we just need to take height to be common. So what I'm going to do, I'll do the working over here. Pi r square h is the volume of the volume. This is of P. Just going to denote this by P, plus pi r square h of Q is equal to, what was the total volume we calculated? 90.5 pi. So let's plug in the values. Pi into 3 r square. R square is of P is 3.5 into h, plus pi into r square of Q is 8 into h is equal to 90.5 pi. Now we just need to simplify this and solve for h. The reason why we can take h to be common is because they're asking us that water is to be moved from tank Q to tank P so that the height of the water will be the same in both tanks. That's why h can be common between the two. And that's why we need to calculate the new height. So pi cancels from everywhere. 3.5 plus 8. 3.5 plus 8 is 11.5. H is equal to 90.5. So 90.5 divided by 11.5. 90.5 divided by 11.5. 7.87. 7.87. Approximately the answer would be D, 7.9. At a certain furniture shop, the price of a table is $4 and the price of a chair is $6. The store sells H tables and T chairs for a total price of $456. So the price of each table is 4. He sells H tables. And the price of each chair is 6 and he sells T chairs for a total price of $456. That's his total revenue. Which of the following statements must be true? Indicate all such statements. So this is the answers could be options could be more than one. All three of them could be correct. We'll have to check. So they haven't told us what H and T exactly could be or what they may not be. So let's take option A for instance. Let's check this one. H is less than or equal to 81. If for instance, if we can take an extreme. Let's say he sells no chairs. He sells 0 chairs. Nothing is specified. T can be equal to 0, and if T is equal to 0, then 4H is equal to 456. H is equal to 456 divided by 4, 114. 114 does not satisfy this equality. As a result, option A is wrong. Since the reason why it's wrong is because T could be anything, right? There's not specified. He could sell 0 chairs, and as a result, he'll sell all tables. H need not necessarily be less than or equal to 81. Let's check option number B. T is less than or equal to 33. We can just reverse it. Let's say he sells no tables. Let's say he sells 0 tables. H is equal to 0. So 6T would be then equal to 456 without any tables being sold. 456 divided by 6. T would be equal to 76. And 76 does not satisfy this inequality of being less than or equal to 33. As a result, option B is also wrong. Without even doing any further checking, since options A and B are wrong and one of them has to be correct, answer C will be the answer. But let's check. Option number C. H plus T is less than or equal to 114. So we've already seen the extreme cases when T is equal to 0, H is equal to 114, and when H is equal to 0, T is equal to 76. If we increase T by any value, if we put T any value over here, whatever value for H we'll get, and when we sum those two, H and T, they will always be less than 114. Simply because of this extreme case that we've already seen. When T is equal to 0, when it's on the minimum, H will be equal to 114. I can also, let's just take an example. Let's say T is equal to 5, or let's say T is equal to anything for that matter, absolutely anything. Let's say 5. 6 into 5 is 30. 456 minus 30 divided by 4. H comes out to be 106.5. 106.5 plus 5 plus 106.5 is 111.5, and this is less than or equal to 114. Basically, any value for T or H for that matter, the sum of them will always be less than 114 because of this extreme case. When T is equal to 0, H is equal to 114. And it's not possible for the sum of these two would be less than or equal to 114. And we've already know that A and B are 100%, need not necessarily be true. They may be true, but they need not necessarily be true. So by the process of elimination, we can see that C will always be correct. I hope you understand. So we're on the last question now. Question number 12. If the area of trapezoid PQRS is 150, what is the length of side RS? So I'm just going to extend this over here. This is also equal to 8. This is also equal to 15.75. If the area of trapezoid PQRS is 150, so this is a rectangle OPRQ, 15.75 into 8 plus this ORS is a triangle, so 1 over 2 into, we already have the height, and let's say OS is equal to x. X is equal to 150. Let's find x first. 15.75 into 8, 126 plus 2 ones are 4 plus 4x is equal to 150. 150 minus 126, 24. 4x is equal to 24. X is equal to 6. So this is equal to 6. What is the length of side RS? This side, y. Let's just suppose it's y. So we have 8, we have 6. Now we can just apply the Pythagoras theorem. Y square is equal to 6 square plus 8 square. 36 plus 64 is equal to 100. Y square is equal to 100. Y 100 under root is 10. So this will be exactly 10. So I've solved the basic quant section of Saad's new mock exam that is uploaded on his Instagram. Make sure to solve this paper on your own using Saad's Instagram, and if you have any concerns or questions, please comment down below. And as I mentioned before, Saad will address those concerns directly himself. So I hope you enjoyed the video, and take care. Thank you.